Hello friends, how are you? I hope you all are well. Today in this video I am going to explain about the electric motor, which is one of the important component in your fan, mixer, washing machine, computer, etc. So it is one of the important concept of the topic magnetic effects of electric current. Then question comes, what is an electric motor? I can say that it is an arrangement. The arrangement in which a rectangular coil rotates continuously in a magnetic field. So I can say that it is an arrangement in which a rectangular coil rotates in magnetic field. In fact, it is a rotatory motion which converts electrical energy into mechanical energy. Let us discuss about the principle on which the motor is prepared. In this topic, we are discussing about the DC motor according to your syllabus. I am discussing about the DC motor. So, what is the principle of that motor? A DC motor works on the principle. A DC motor works on the principle that when a current passes through a conductor which is placed normally in the magnetic field, a force acts on the conductor which, or I can say that as a result, it rotates and thus a mechanical energy or work is obtained. That means if a current carrying conductor placed in a magnetic field perpendicularly with the direction of the magnetic field, a force acts on the conductor. As a result, the conductor moves. When conductor moves, electrical energy convert into mechanical energy. So, the direction of a force acting on the current carrying conductor can be obtained by using the Fleming's left hand rule. So, let us first discuss about the construction of this DC motor. The principle, I said that a rectangular coil carrying conductor rotates in the magnetic field when it is placed perpendicular with the direction of the field. So at first we will discuss the construction part. So construction, what are the different parts? First one is the armature. What is this armature? It is nothing but a rectangular coil. In practically, this coil is wound on soft iron core. This is just like a rectangular iron sheet on which this rectangular, the copper coil is wound. This is armature. So the rectangular coil with that soft iron, that is called the armature. This is the soft iron core over which the coil is wound. One is the armature. Second point. The second part is the horseshoe magnet. I have mentioned here horseshoe electromagnet. We can use also permanent magnet. Generally, we prefer to use electromagnet. In place of horseshoe magnet and other bar magnet also we can use. But we have to use two bar magnet, one this side, one that side. But in this figure, I have mentioned horseshoe electromagnet. So armature, magnet, these two are called the split rings. Split rings S1 and S2. Fourth point, two carbon brushes. Fifth point I can mention DC source. A DC source or battery. These are the major parts. So this is the rectangular coil. Don't think that only one turn of coil. Not like that. Number of turns of coils are there. These are the two ends of the coil. These two ends of the coil are connected with split rings. One split ring divided into two parts, you can say. This is split ring. So one is S1, another one is S2. The S1 is in contact with the brass. This is the carbon brass. In fact, metallic brass like that. Okay? Two brushes B1 and B2. Why we have taken the carbon brushes? You may think that this conductor, metallic conductor, we can make it contact directly, but there is a problem. If this is a brass, this is somewhat soft brushes. Number of thin wires are there in that brass. When the coil rotates along with the split rings, through the brass current flows. Brass will not damage the surface of the split rings. In place of the brushes B1 and B2, if I use the strong metallic wire, there is a chance that during rotation time there may be disconnection. Second thing is that it may damage the surface of the split rings. For that purposes, both side sheet two brushes B1 and B2 are in contact. The split rings S1 and S2 are mounted over an axle. This axle is a support to this system. So this split rings can smoothly rotate on the surface of the axle. So here is the circuit, key, source of energy, DC source, battery. Here is one rheostat. By the adjustment of the rheostat, we can allow varying amount of current. Okay. So this is about the construction. This N and S are the north and south pole of the horseshoe magnet. Now let us discuss how does this motor work. Listen carefully. In fact, the direction of magnetic field, we assume from north to south. North to south is the direction of the magnetic field. We have placed the conductor exactly perpendicular to the direction of the magnetic field. This is the AB. Now, if I on the key, the current flow according to conventional direction of current from higher potential to lower potential, current goes enter into the brush B1, thereafter it enter into S1, it moves like this manner and it leaves the circuit through S2 and B2. So, at this time, you observe from this figure, the magnetic field and the current carrying conductor at the side AB and CD both are perpendicular. Now it is perpendicular because we know that if a current carrying conductor placed perpendicular to the direction of the magnetic field, a force acts on the conductor and we can find its direction by using Fleming's left hand rule. Already we have studied Fleming's left hand rule. What is that Fleming's left hand rule? If forefinger, central finger and thumb are stretched mutually perpendicular to each other, if forefinger shows the direction of the magnetic field, central finger shows the direction of the current, then thumb shows the direction of force or motion of the conductor, you can say. Now you see that these two are perpendicular. So when it is perpendicular, a force acts. Which force direction is downwards, or I can say if this is the rectangular coil, this is the current, this is the direction of magnetic field, this one will be the direction of motion of the conductor. These three are mutually perpendicular to each other. So, the side AB a force act downwards. At the same time, this side also perpendicular. But here the current direction A to B, here the current direction is C to D. In this case, force act upwards, perpendicular. Here also force act perpendicular to the horizontal surface but outwards. In this is the rectangular coil. One side the force is acting downwards, one side force is acting upwards. That means I can say that a pair of equal and opposite forces are acting, or you can say that there is a couple. Couple is nothing but a pair of equal and opposite forces which act on a body and creates a turning effect. So, in this case, let us see BC and AD. In this arm, these are the arms of the rectangular coil, you can say. In this arm, you see that direction of current, direction of magnetic field, both are parallel. We know that if both are parallel, no force will act. So, we are not worried about the BC and AD. In higher classes, when we study, there may be little angle will become, there may be little forces, but that force will not affect it in rotation. That's why we are not considering this side. Just I said that these are parallel, that's why no force acting along BC or AD like that. So, the forces are acting, one is side AP, one is side CD. So, now the coil starts to rotate anti-clockwise. Now the coil starts rotate anti-clockwise. If it starts rotate anti-clockwise, what happened in the beginning? Now it is in horizontal position. So when it starts rotating after 90 degree, it will come to the vertical position. So when it comes to the vertical position, that means see these two split rings will be like this. So the process will be like this. That means after 90 degree, there is no supply of current. There is no supply of current, no force will act on the conductor. But due to momentum, the conductor will continue to rotate. So once again it rotates. Suppose it rotates another 90 degree. When it rotates another 90 degree, okay, first 90 degree, this is the S1, this is the S2, this is the brass B1, this is the brass B2. Okay, this is after 90 degree, means from horizontal when it comes to the vertical. Again, when it continue to rotate due to momentum, then what happened? The S1 comes to this side and S2 comes this side. Now the brass B1 is in contact with the S1 and brass B2 is in contact with the S1 and brass B1 is in contact with the S2. That means now current is entering from B1 to S2, starting B1 to S1, now B1 to S2. That means the direction of a current started changing when reached that 180 degree rotation. That means after half cycle, the direction of a current changed. But this side, now AB, force is acting downwards. Now it is downwards, vertically. Again it came to this side. That means now started force acting upwards. That means at present AB, force is acting downwards. But after 180 degree on this side AB, it is acting upwards, and this side, when it comes to this side, it is acting downwards. As a result, the coil continue to rotate in one direction. Here, after half cycle, the direction of a current is changing, but coil will rotate continuously in anti-clockwise direction. So the split rings help to change the direction of a current. As a result, the coil able to rotate continuously in one direction. The fact is that when this side is AB, current is going like this. When this one comes to this side, current is moving like this. Okay? So this is about the working of a DC motor. Then, how can we increase the speed? We can increase its speed by increasing number of turns. Increasing number of turns of the coil. What other things are there? Yes. By increasing area of the coil. By increasing area of the coil, Also we can increase the speed by increasing the strength of current. That's why here rheostat is there. With the adjustment of the rheostat, we can vary the amount of current. Again, by increasing the strength of the magnetic field. So, by increasing the number of turns, by increasing the area of the coil, by increasing the strength of the current, or by increasing the strength of the magnet, we can increase the speed of this rotation of this rectangular coil. So, I hope that you might have understood it very clearly. So, until the next video, bye.